Today we are going to discuss about what is complex number. So in the plus 2 we have learned about what is complex number, and in your unit 2 we are going to discuss about what is complex analysis and what is complex function. So when we are talking about complex number, we are saying a plus ib. So we have some structure in the form of a plus ib. So the complex number which is extended from the real number. So the complex, its meaning is the number which cannot be defined, its meaning is called as a complex number, which is bigger compared to all the numbers. So the origin of the complex number is defined from real analysis when we are calculating the roots of an algebraic equation. So it is called as x square minus 1 is equal to 0, it's called as an equation, it's an algebraic equation. So we are going to define the roots for x. Okay, wow. So when we are calculating x square minus 1 is equal to 0, when minus 1 moves to right hand side, we are saying x square is equal to 1. So we are saying the value of x is nothing but plus or minus. Similarly, when we are come for an algebraic equation in the form of x square plus 1 is equal to 0, which is a quadratic equation, we know that for a quadratic equation, we have two roots. So that we are saying x square is equal to minus 1. So we are saying x square is equal to root of minus 1. So when we are saying we have a minus under the root, we are saying which is cannot be calculated, which cannot be defined. So such a number is called as the complex number. So that we are defining the form of complex number as z equal to a plus ib, where a and b are the real numbers. When it is combined with I, we are saying it as a complex. So where we are saying a is a real part of z, b is the imaginary part of z. So for your unit, we are coming for complex variables and complex functions. So what is complex variable in sense? In terms of constant, we are taking a variable. Okay, right? So we are defining z equal to x plus I. So where the constant we are taking it as a variable, the variable, that's meaning is we are defining a value. Okay, right? So z equal to x plus I by where it is defined on the two-dimensional graph, where it is defined as a real and imaginary axis. So the structure of the complex variable, we are saying z equal to x plus iy, where we are saying x is a real part of z, y is the imaginary part of z. When we are defining a variable, x and y are real variables. Similarly, when we are coming for a complex function, we are saying the number we are transforming into some other structure by using some functions. Okay, wow? So we are defining a function f on a variable. So the structure will be converted to a complex function. There we are saying f of z is equal to, z is a variable, f is a function which is applied. So x and y will be transformed into another function in the form of u plus iv, where u and v, they are depending on x and y. So the structure of a complex function, we are saying f of z is equal to u x comma y plus I v of x comma y. So generally we define the complex function as in the form of f of z is equal to u plus I v. So that the complex number which will be helpful for us to calculate the analytical function. The analytical function meaning is the function is to be exist for some condition, that is called as the analytic. So some certain point the function to be exist. Okay, because the function it cannot be extended for all the values. So when we are calculating the analytical function, that is an analytical function by using complex, we are using CR function. That is nothing but CR equation. You have been learned, I think so, the CR equation. By using the CR equation, we are calculating the complex function, which there we are saying the points are existing on that. So what is CR equation in sense is the real and the imaginary part of any analytical function satisfies the CR equation we are saying. So the condition of the CR equation is nothing but u it is defined, that is derived with respect to x, v it is derived with respect to y. So u and v are equal, and I am saying that u it is derived with respect to y and v it is derived with respect to x, and its negative value we are saying as CR equation. So the CR equation must be satisfied in the condition of ux is equal to vy, uy is equal to minus vx, where we are saying that it satisfies all the analytical functions. Similarly, we are coming for the complex integration and complex, that is theorem. When we are coming for complex integration, we are saying that the complex integration will be satisfying the CR equation. Okay, so this complex number where we discussed is regarding to the structure of the quadratic equations. Okay, in the next class we'll define some other topic in the complex analysis. Thank you.